3238. Detonation may occur at high power settings when A. The fuel mixture ignites instantaneously instead of burning progressively and evenly. B. An excessively rich fuel mixture causes an explosive gain in power. C. The fuel mixture is ignited too early by hot carbon deposits in the cylinder. The correct answer is A. Detonation may occur at high power settings when the fuel mixture ignites instantaneously instead of burning progressively and evenly. In an engine operating under high power, the fuel mixture should ignite in a controlled and timed manner, allowing for a smooth and efficient combustion process. However, if the fuel mixture ignites all at once instead of burning progressively, it can create a rapid pressure rise within the cylinder, leading to detonation. Detonation can cause engine damage and should be avoided by using proper fuel/air mixtures and following recommended operating procedures. 3238-1. Detonation occurs in a reciprocating aircraft engine when A. The spark plugs are fouled or shorted out or the wiring is defective. B. Hot spots in the combustion chamber ignite the fuel/air mixture in advance of normal ignition. C. The unburned charge in the cylinders explodes instead of burning normally. The correct answer is B. Detonation refers to the rapid and uncontrolled combustion of the fuel/air mixture in an engine's cylinders, resulting in a sudden explosion. This phenomenon generates intense heat and puts significant mechanical strain on the engine's components. Detonation occurs when the air/fuel mixture ignites at multiple points within the cylinder simultaneously, instead of a controlled and gradual burn. The uncontrolled nature of detonation can lead to excessive pressure and temperature spikes, potentially causing damage to engine parts such as pistons, cylinder heads, valves, and connecting rods. Proper engine management, including the use of appropriate fuel grades and maintaining correct engine operating parameters, is essential in preventing detonation and ensuring the safe and efficient operation of the engine. 3240. The uncontrolled firing of the fuel/air charge in advance of normal spark ignition is known as A. Combustion. B. Pre-ignition. C. Detonation. The correct answer is B. The uncontrolled firing of the fuel/air charge in advance of normal spark ignition is known as pre-ignition. Pre-ignition occurs when the fuel/air mixture ignites before the spark plug fires, often due to the presence of hot spots or excessive heat in the combustion chamber. This can lead to a rapid and uncontrolled rise in cylinder pressure and temperature, which can cause engine damage. Pre-ignition should be avoided by using proper fuel grades, avoiding excessive heat buildup, and ensuring the ignition system is functioning correctly. 3242. What type fuel can be substituted for an aircraft if the recommended octane is not available? A. The next higher octane aviation gas. B. The next lower octane aviation gas. C. Unleaded automotive gas of the same octane rating. The correct answer is A. If the recommended octane fuel is not available, the next higher octane aviation gas can be substituted for an aircraft. It is important to use a fuel with an octane rating that meets or exceeds the engine manufacturer's requirements to prevent detonation and ensure proper engine performance. Using a higher octane fuel than recommended provides an extra margin of safety, but using a lower octane fuel can lead to engine damage and reduced performance. 3243. Filling the fuel tanks after the last flight of the day is considered a good operating procedure because this will A. Force any existing water to the top of the tank away from the fuel lines to the engine. B. Prevent expansion of the fuel by eliminating airspace in the tanks. C. Prevent moisture condensation by eliminating airspace in the tanks. The correct answer is C. Filling the fuel tanks after the last flight of the day is considered a good operating procedure because it helps prevent moisture condensation by eliminating airspace in the tanks. When there is empty space in the fuel tanks, it can create room for humid air to enter and condense, leading to the accumulation of water in the fuel. By filling the tanks completely, the airspace is minimized, reducing the opportunity for moisture to form. This helps maintain the quality of the fuel and prevents potential issues associated with water contamination in the fuel system.